Hello, today we're going to be degreeing the camshafts on this BMW M50. So what we're actually going to do is measure the lift of the cam relative to the angle of the crankshaft. So I've got the motor all assembled and set up. I've got the cams installed. I'm actually going to be degreeing these cams in this motor to 6 degrees retard on the intake and 4 degrees advanced on the exhaust. So the cams that are in this motor are a set of NM 276 cams, and the box says that they're 109 degrees lobe center angle on the intake and 111 degrees lobe center on the exhaust. So with these cam timing settings, we should be at 115 degrees lobe center angle on both cams. So I've got a dial indicator set up here on the first lobe of the camshaft, and I've marked the harmonic balancer with degree marks. So these motors have a 60-tooth crank trigger wheel on the front, and 360 degrees divided by 60 teeth is 6 degrees per tooth. So I've marked that out on the balancer, and rather than using a degree wheel, I'm just going to use the trigger wheel on the balancer to measure the crank angle. So here's the trick for measuring the lobe lift here. I've taken a spare lifter tray. Sorry, I'm having trouble with the camera angle here. I've got a spare lifter tray, and I cut the end 2 lifter buckets off of it, and I've just stuck that on top of the cam, and then I've holding it down with a piece of electrical tape. So there's a lifter in there with the dial indicator sitting on top of the lifter. So the cam will be lifting this lifter up, and we'll be measuring the lift on top of that lifter. So this is like 180 degrees out from what it would be if we were measuring the lobe going down. So usually what I can do with most of these M50 cams is I will just tape a little piece of welding rod onto the dial indicator stem, and I'm usually able to get it stuck down past the cam lobes and sit on top of the lifter so I can measure the lift that way. But with this particular cam combination and these lifter trays, I just cannot get a dial indicator past the cam lobes to be able to measure it. So I'm using this trick that my friend Will taught me of using a piece of another lifter tray on top. So got everything set up so we can start turning it. So I'll take my timing blocks off the cams, and I guess I will just start turning the crank. Now this setup does have a solid lifter conversion in it, and the cams are lashed to 10 thousandths of an inch. So I'm going to turn the crank until I see 10 thousandths of an inch of lift on the lifter, because that will be the lash amount. So that's how far it has to travel to take up the lash. So we need to go almost 1 full rotation here before we'll see any lift. There we're starting to see some lift. And there we're at 10 thousandths of an inch. So I'll check the marks on the balancer here, and I'm sorry you're going to be staring at the back of my 32-year-old bald head for most of this video. But we're measuring, I'm going to call that right about 26, 27. All right, it's 26 degrees before top dead center is where we got to 10 thousandths inch lift. So keep turning the crank. The next point that I'm going to measure to is to 40 thousandths of an inch of lift on top of the 10 where I already am. So I'm going to turn until the dial indicator says 50. There. So that's 1 millimeter of lift. So we are at right about 8 degrees before top dead center. The next point I'm going to go to is 50 thousandths of an inch. Right there. And that is 5 degrees before top dead center. So I'm writing all this down on this card here, and I'm going to keep measuring all of these, but I'm going to speed up the video here just because this is redundant and you don't need to keep staring at the back of my head. But I'm going to fill out the rest of these lift values. So I just crossed the point of peak lift. So the dial indicator went up to 450. So if we subtract our 10 thousandths of an inch of lash, our net lift is about 440 thousandths lift. All right, so we've got all the measurements done for the intake cam. So now we just have to do some math and figure out what these all add up to. So for the 10 thousandths of an inch to 10 thousandths of an inch measurement, I get 268 degrees. That's a little bit less than the advertised duration on this cam, just because we're measuring it from 10 thousandths of an inch lift, and typically most import cams measure the seat to seat dimension from like 4 thousandths of an inch to 4 thousandths of an inch, which is probably what it will actually be when the valves are hot and it's running. And then our 1 millimeter to 1 millimeter is exactly 230 degrees. And I think these cams were advertised to be a little bit more than that. I think they were supposed to be like 236. And our 50 thousandths to 50 thousandths, we are at 224. So yeah, the cam is a little bit smaller than it's advertised to be. It doesn't quite match the duration that's listed on the cam card. Part of that is because I'm measuring at 10 thousandths inch lift versus the cam card is probably written at 4 thousandths of an inch for the starting lift. But in any case, that's the results we got, so it is what it is. And also the lobe center angle does not match what the box says that the lobe center angle is, but this is a perfect example. This is why we degree the cams, so we actually know what they're at. So if I was to install this cam without any cam timing blocks or anything, for one thing, the intake valves would hit the pistons, but the intake center line, if I were to use the factory cam blocks, would be like 100 degrees, which is like silly advanced. But in any case, you know, that's why we test these things, and it'll be totally fine. Now that we know what the intake center line is, we can adjust for it, and I'll just use the correct cam timing blocks and I'll put the cams where they should be, and everything will be good. So the next thing I'll do is I'm gonna move this little lifter fixture over to the exhaust. So then I'll do the exact same process over again on the exhaust. So I'll profile the exhaust and figure out what the center lines and what the duration is, and should be good to go. All right, thanks.